When we have huge amount of data from a rainfall gauge station, we may be able to predict future rainfall reliably. Let's say we have a set of historical annual rainfall depth data collected by a station. Within the 25 years period, 10 of them recorded rainfall depth greater than 100 cm. Given the fact where rainfall is a random process, what would be the probability of annual rainfall depth exceeding 100 cm for this station? To do this, we need to rearrange the data in descending order. Order number denoting the rank of a specific value in this list is then assigned. At this point, the greatest rainfall depth ever recorded within a 25 years period should carry the order number of 1. Meanwhile, the lowest value should be associated with the order number 25. Next, we can determine the probability for the occurrence of certain rainfall depth using Weibull formula. In this formula, m is the order number for individual entry, while n is the total number of entries, which is 25 in our example. Once we obtain the probability for all the rainfall depth entries, we will calculate corresponding average recurrence interval, ARI, aka return period. It simply equals to the inverse of the probability. For the first entry, ARI equals to 26 years. We can say such record will be hit once every 26 years. In 100 years, we are expected to have about 4 of such occurrences. After that, we may plot a graph of annual rainfall depth against return period. Note that we should plot the horizontal axis on logarithmic scale. Then, let's draw the best fit line for the data and determine its equation if possible. Back to the question earlier on. What is the likelihood of 100 cm rainfall depth within a year? We can either find it from the graph or the trendline equation by using rainfall depth equal to 100 cm as our input. The output from this method is ARI, and we can inverse it and retrieve the probability. Besides Weibull formula, we also have several methods at our disposal. We are free to use them as an alternative for Weibull formula. Other than that, all the other procedure and calculations shall remain the same. Thank you for watching. If you find this video helpful, please share it with your friends. We will see you guys soon. Goodbye.